Dear students, so in a last lecture we discussed about what is the conventional computing and what is the deep learning and what is the differences between the conventional computing and deep learning, right? And also we discussed the limitations of the deep learning, right? And how the conventional computing is work in real-time environment. These are the things we discussed in the last lecture. So today lecture we is going to discuss about feed-forward neural networks and backpropagation. We are going to discuss about this one. Before going to the actual content of today presentation, we will discuss the outline of today presentation. So mostly the today presentation will be two categories. So one is a feed-forward neural networks and architecture. Single neuron understanding of learning problem. This we will discuss, and next we will discuss the backpropagation. What is a backpropagation and why backpropagation will work? Training process, advantages and limitations we will discuss at the end of today class. Right. So first one, what is a feed-forward network? Feed-forward neural network. Right. So information flows in a one direction, like that means that there will be some input layer, so there will be some hidden layer, some output layer. So data will flow from one direction only, from input to the hidden layer to the output. Data will not come back from this to this. So this is not called as a feed forward neural networks. So that one we call it as a RNN, recurrent neural network. So that one we will study later on this course, right? So it is a very simple and one way of processing. How will identify the whether it is a feed forward neural network or not? Simple. If it is don't have any cycle or loops, so then we can say it is a feed forward neural network. So characteristics of feed-forward neural network is a unidirectional data flow, as we see previously, like data will be flow like this one, this direction. So one input layer, something like that. So there is no memory of past inputs. So that means that some data is processed here. For example, take this layer. This is one layer. So what is the data is processed? This data is not used in this one. So process the output only this data will be used. So there is no connection between like this or like this. So this we call it as RNN, right? So it is a very simple to train and implement, right? These are the characteristics of the feed forward neural networks. So common application, classification and regression, pattern recognition. So what is a classification? For example, there is a one cat images and dog images, let us say. So you will develop the one model which will able to identify the given image is a cat or dog. So that is a classification. What is a regression? Regression means, for example, there is a house. Let us say there is a one house. We want to predict the house price, right? So normally house price prediction, what are the elements are involved? It means that if you want to predict the house price, what are the influencing factors of house price? Area, number of floors, right, and type of construction, etc. So these are all factors influenced by the house price. So based on these factors, this will be predicted. Right, so this one we call it as a regression problem. Pattern recognition, simple we can say face recognition, etc. Right. So these are about the basic definition and characteristics of the feed forward neural network. Next one, so architecture of the feed forward neural networks. So there will be some input layer and their output layer. There are different hidden layers. So input layer and output layer only one, but hidden layers are there is a chance of many. But here I am showing only one but there are many in a real time. So in an input layer, what will do? Input layer receive the raw data. So that means the input layer act as a receiving information from raw data, information from data set, or we can say some data format, etc. So hidden layer what will do? Actual hidden layer, this hidden layer do the actual computation. So actual it will do the computation process. What are the computation is required for our application or our requirement, it will do that. So it will perform the computation and transformation actual. So output layer will give the output as a classification or prediction. So these are the three major layers from the feed forward neural networks. What is a neuron? You can say simple, it is a simple computing, small computing element. So we can say small computing element. So next one is a connections. What is the connection? Connections also called as weights. So you might see in this this neuron having 1, 2, 3 connections is there. This one we call it as a connections or weights. So what will do? It will having associated some weights. So what is a weight also I will tell you. For example 0.7, 0.6, 0.1. These are the some weights. Right? Just I am giving example. It not necessarily like correct answer. It maybe depends on the application. It will be changed. So what is a bias? Bias is a some term, right? It is a bias term. So implement shown in a diagram. For example, b equal to 0.1, 0.2, etc. something. So when your actual discussion will come, you will understand the clear what is a bias, right? So next, how the single neuron work. So actually single neuron, how it is working, we'll see now, right? For example, a single neuron having multiple inputs. You might seen previously this one. You can see this neuron having 3 inputs. So this neuron also having 3 inputs. Like there will be having multiple inputs. So it's also associated with the weights, sum, bias, and activation function. Right. What is the weighted sum? For example, take the simple neural network architecture. So I am not writing here input layer and output layer. So just I am giving idea to understand. For example, let us say this is a neural network architecture. Let us say. So for example, this is a 0.2, this is a 0.3, this is a 0.4, this is a 0.5. Let us say. So in that cases, so weightage will be of this link is a 0.2, this is a 0.3, this is a 0.4, this is a 0.5. So if you want to calculate this computation, what is going on, that is 0.2 of some data is flowing from this neuron to this neuron. So let us say that is 0.3, right? So that is WI. WI is a 0.2, XI is a information, right? Plus summation is there, plus. So what is the one more is there? Here it is a 0.4. So 0.4 plus some 0.7, right? So this one 0.2 is a weightage. Here it is a 0.4 is a weight of this connection, right? So in this way, the sum will be calculated plus some bias term will be 0.1 or 0.2, so something like that. So you will get some value, right? So after calculating this, doing all this mathematical analysis, you will get some value. So let us say assume just that is 0.7. Just I am giving example. It may not be compulsory correct. Just I am giving example. Let us say 0.7. This 0.7 is associated with this neuron. This 0.7 data should be passed to the next layer or not. So that will be decided by the activation function. So that activation function will be different activation function, that is sigmoid activation function and ReLU activation function, TANH activation function. We will discuss the examples, some of the examples with activation function in some other classes. But remember, activation function, what will do? It will pass the information to the next layer. It depends on the activation type. For example, ReLU activation function max of 0 comma x. X is a value which is coming. For example, here it is a 0.7, you can say 0 comma 0.7. So max is a 0.7. That one you can take. This 0.7 will be passed, depends on your application. Like if you are putting threshold is 0.5, then it will pass. If threshold is 0.9, it will not pass. So in that way, it is going to be pass the information. So what will do? Actually, our activation function will do. It introduce the non-linearity to allow the complex patterns. So these are the activation function purpose, right? So we'll see some of the example with further classes, right? Next, so feedforward pass in FFN. So how it is actually work, step by step process. So we already seen. So these are some input layer. This is the output layer. So there will be some one or more hidden layers, right? So input data feed into the input layer. So what is the data is coming? That data is feeded, and each neuron in a hidden layer calculate the weighted sum of it inputs the previous layer. So in an input layer, like there will be different inputs like this. So each and having connection, right? So like this. So there will be some connections, right? So how we previously it is we shown a calculation. So this fashion the data will be calculated, right? So data will be calculated and applies the activation function. So output from the each input layer we come to the next layer. So what is the data is coming here? So it is act as a input to this layer. So similarly, what is the if one more layer is there, this data act as a input to this layer, and so on. It will go for the till output layer. So output layer will do simply it will predict the output, right? So we can say it is a output layer will produce the output of our function, right? Next one. So understanding of learning problem. So goal is to what is our goal? The network make the accurate prediction. So that means that, for example, there is a layers like this. Let us say this is the input, this is the output. Let us say. So there will be some connections like this, right? So what is our goal? Goal is to predict the actual output. So that will be fine. How your output will be accurate based on the best or optimal weights and bias. So what is the weights and bias will coming from here? So based on these inputs, so output will be predicted. That is our aim, right? So in that cases there will be chance of error. So for example, take this input something like that, right? So this is output you take, this is the input you take, let us say. Right. So for example, output should be 100, right? Output should be intended to value should be 100, right? But output came 90. So what is the error? Error is 100 minus 90. Error equal to 10. That is a error. So what we have to do? Quantify the difference between the network and predicted one and target output. Our target output is 100. What is the network is predicted? Network is predicted 90. So what is the error percentage? Error percentage is 10%. So that is a error. So here it is a y predict and y true. That means that what is the actual output intended to come, but actually it is came, right? So that is the error. So there is a two types of error category. That is a mean square error. Mean square error is used for regression type of classes. regression type of problems, and cross entropy for classification problems. So these are the different types of categorization errors. So that means that problem is classification problem, the error will be different. So problem is regression, the error will be different. So those different types of functions we are going to use to identify the errors in this classification or regression kind of problem. So what is optimization? What is our optimization? Optimization is to minimize the loss function. So that means that, for example, here is a loss at 10%, right? 10%. This you want to minimize. For example, 100 is intended to come, but it came 99.99. So this is our intention. We want to minimize the actual error. So that is the optimization. How we are minimizing? By best apply the weights and bias terms. Weights and bias term. If you are providing better way, optimal way, the output will be good. Output will be good means indirectly error will be very less. So next one, introducing the backpropagation and learning algorithm. So that is about a feed-forward neural network. So in a backpropagation, what will do? So in a backpropagation, let us say this is the input layer. There will be some hidden layers, right? So let us say we want to minimize the error, but unfortunately error came more. So in that case, what we have to do? How the error will be minimized? Just now we see by applying the best weights and biases. So you can minimize the error. So how we are doing that one? You will propagate the gradient into the back like this, so that it will be adjusted automatically. So what is the gradient? Gradient previously we see 100 minus 90, which is equal to 10. This 10 we call it as a gradient. So what we will say? Indirectly, this 10 is came here. This 10 will be passed to the previous layer, so that these layers will automatically adjust the weights and bias term, and weights and bias term similarly adjust to here also, this term also, so that automatically this gradient will pass to the starting of this layer, and it will try to calculate the again loss once more time. Like first it will go and it will obtain error, it will compare the error percentage. If it is desired one, leave it. If it is not desired, data will be passed again like this. So again will go like this, again it will go like this. It will n number of times it is going to repeat, right? So what will do? So efficiently calculate the gradient loss function with respect to the each weight and bias term. So efficiently it is able to identify the gradient and gradient, so that it will be find the optimal weights and bias term. So in that, how you are doing that one? It will be adjusting the weights and bias term, right? So for that one, what you have to do? You have to apply the chain rule calculus. So mathematics, so dou W by dou L, something like that. So weights will be adjusted with respect to the loss. So it is a chain rule, mathematics. So it is a +2 mathematics, right? So now, and based on this one, it is going to be calculated. So first one is a backpropagation algorithm. Forward pass data will be as we discussed previously. So next we calculate the loss. So in a backward pass, what it will do? It will come to the backward. So as we discussed, input layer, hidden layer, it will go based on the error term, it will pass again. So again it will go, some error will be minimized or maybe maximized, based on that one it will come again same, again till the time the error will be minimized. So that one we call it as a backward pass or error propagation, right? So each time what will do, just it is updating. What it is updating? Weights and bias terms. So there will be some weights here na, the weights and bias term will be updated with respect to the gradient descent. That is like del w is equal to eta of dou w by dou L. As previously we see, with respect to loss, the weights will be updated. Eta n is a learning rate. How here it is learning? Like learning rate may be 0.1, 0.2, etc. like this. So this is back propagation is algorithm will work, right? Next, so why back propagation will work, right? Next question is why back propagation will work, right? So in that case, so backpropagation is efficient way to apply the chain rule. So why backpropagation will? Because of it is a applying the chain rule property. Chain rule property is a +2 mathematics. So that's why it is working better. So avoid the redundant calculation. Also, here propagating the error. So it means that it will unnecessary calculations is not performing. Same time, why it is not performing? Because of it is propagating the error to the backward passes. So what it will do? It also same time allow the network will allow the complex learn the complex non-linearity relationship by adjusting the internal parameter. What is the internal parameters? Weights and bias. So by adjusting the weights and bias, it is going to be learn the non-linear parameters, right? So next one, training process. So what is a training process? First one is a epoch. So one complete pass from the entire training data set through the network. So that means that one starting to input layer to the one output layer. So this one we call it as a epoch. One epoch, right? One epoch from where the data input is passing. What is the one gradient is finding. So that one we call it as a epoch. What is a batch? Training data is divided into the smaller batches. So what is the training data? So training data is simple, we can say input data. So that we can call it as a training data, right? So it will be divided into the different batches, like batch 1, batch 2. So that one we call it as a batch. Iteration. So iteration, as of my knowledge, so iteration, what is the iteration? You no need to explain for this those who are listening this lecture, because they might already know what is iteration. Even though I try to cover the what is iteration, is a process of forward pass, large calculation, back propagation, update weight, repeat many epochs until the network performance is satisfactory. So that means that one complete cycle process is completed. So that one we call it as a iteration, right? Next, advantages of FNN, feed forward neural networks and back propagation. So it is a very simple and efficiency and versatility. So that means that you can apply for the classification and you can apply for the regression. So whereas a back propagation, it's enable the training of deep learning from the basis of many advanced neural network architectures. So that means that we can say is a back propagation is a base for many advanced deep learning algorithm. So this is one of the advantage for feed forward neural network and back propagation. Next, limitations or challenges of this FNN and back propagation. No memory for sequential data. That means that this sometime it is a problem also. Why it is a problem we will discuss in the further classes, but right now you remember this is one drawback. So back propagation, there will be vanishing or exploring gradient problem. So briefly I will explain what is a vanishing and exploring gradient problem. For example, your target is to predict 100, but actually it is came 90. So you take like this. There is a one curve you take like this, right? So what is the difference? It is a 100. So that means that what we have to do, we have to reduce the batch size towards this side, and same time this also we have to reduce. So it will reach to the some certain point. So both are coincide with one point, right? So that point means this actual predicted value and actual value both are coincided. The error will be very minimum, right? So in that cases, what you will do, the training process, the weights and internal mechanism, you try to reduce by batch. So there will be some step size. For example, here is a step size is a very big, let us say. Here also step size is very big. So in that cases, first step like this, second step like this, third step like this, fourth step it will be go like this, and it will be like this. So in that cases, it will never match in a single point of time. So that we call it as a exploring gradient. Vanishing gradient means you have to take very less batch size. So it will never come and reach the single point. So that is also call it as a vanishing gradient problem. So these are the one of the problem in backpropagation, right? So it may stuck sometime local minima. What is a local minima? We will discuss sometime. So one of the local minima we can say model is coming towards the better optimization, but it feel that you don't know some of the point it is a better than this one. So in that cases the model will feel that this is the best one. It is not able to find the optimal one. It is able to find best one but not optimal one. So this is one of the problem. So one of the drawback is a computational cost. So it is a very large network. It requires huge computation to perform, right? So next one is coming to the conclusion. So it is a feedforward and backpropagation is a two of the networks. It is a foundation for neural networks, right? So now I am stopping class here now. If you like my content, please hit the like button and share to your friends, peers, needy people. Thank you for watching. If you have like the content, please subscribe to my channel. If you have any doubt, so you can comment onto the comment box. So thank you.